don't know. I don't think it's harder. Okay, we'll ask you the question. All right, so 7.3 is derivatives of inverse functions. Okay, so this is going to go back and kind of start with reviewing how to come up with an inverse function. And then we're going to derive it and notice something about it. And that noticing thing is going to be really important for what we do in the very next section. Okay, so do you guys remember how you find an inverse? Exactly, and then you just solve. Okay, so you just switch the x and the y. Okay, so this little paragraph right here says the right are the graphs of two functions. We got the original function and the inverse. So remember that if the graph of the first function contains the point AB, then the inverse is going to contain the point BA. So you just flip the points. Okay, and then they're going to reflect over the y equals x line, that dotted line. Okay, so let's do example 1 and kind of see what happens. So first, let's go graph the square root of x. What does the square root of x look like as a function? It is, yeah, so it's a sideways parabola that goes upwards. It's going to cross right through at 0, 0, and then go up. It's going to hit like 1, 1, and like 4, 2, right? For some nice easy points. And go upwards. Okay, so if I was going to find the inverse of that function, to do that algebraically, I would switch the x and the y of my function. So we would say like x is equal to, whoops, yeah, there we go, y squared. Oh my gosh. Y squared. And then if I solve, well, gosh. You guys are ahead of me and I'm trying to follow you. There we go. So you square it and you get the inverse is x squared. But what do you have to kind of think about in this particular case? If I was going to graph x squared as a whole function, it would be a parabola. Would that be the inverse of this particular function?
No.
No. What do I have to do? I have to restrict the domain, exactly. So this one is only when x is greater than or equal to 0. Okay, so you have to restrict the domain in order for the inverse to truly become its actual inverse. Okay, so then we have points at 0 or 1, 1. We would also have a point at 2, 4. See if I can draw that and go up like that. Okay. All right, so I just did C. I graphed them both on the same thing. So now for D, it says to differentiate both the original function and the inverse function. Okay, so I'm going to start with the f of x, which was given to us as the square root of x, which is the same as x to the 1/2. So what is the derivative of x to the 1/2? Yeah, so 1/2 x to the negative 1/2. Which I'm just going to write as 1 over 2x to the 1/2. And the derivative of my inverse function, so I'm going to say f inverse. So I should write this like, see this notation for inverse? So you have like that negative 1. Sorry, I kind of wrote that slide sideways. And then you kind of group it, and then you throw the derivative notation on. Okay, so if the original inverse was, what was it, x squared, what is the derivative of x squared? 2x. Okay, and we can still include that restriction on both. Okay, so for question E, it says find the slope of the graph of f of x at 4, 2. So for my blue one, how would I find the slope at the value 4, 2, or at the point 4, 2? Plug what in?
X.
The x into the derivative, exactly. So I would plug 4 into the derivative, So I have 4 to the 1/2, which is 2, and 2 times 2 on the bottom, I get 1/4. Plug 4 into the blue function from above. Okay, and then it says find the slope of the inverse at 2, 4. Okay, so the slope of the inverse, I'm going to use its derivative, and I'm going to plug in the x value. Whoops, I should write a 2 right here, because now I'm plugging in the 2. So since my function was 2x, I'm going to plug 2 into the x, and I get 4. Okay, so what do you notice about these two slopes? They are reciprocals of each other. Inverse is like, yeah, reciprocals. Reciprocals. Okay, so therein lies our first big, gigantic idea. I actually like this one better. Okay, so basically what you need to realize is that those slopes are reciprocals, so that kind of allows us to figure things out without actually having to find the derivative of your inverse function. Okay, it allows you to take a shortcut. Okay, so what we're going to do on this example is they basically give us, instead of a function, they give us a bunch of points. Okay, some ordered pairs. You guys don't have this? Oh, really?
Oh yeah, we don't got that.
Do you have the example too?
Yeah.
Okay, well just draw this to the side then. Okay, so the first point they give to us, the f of -1 equaling 1, that's the ordered pair -1, 1. You guys see where I'm getting that from? So I'm just using this first piece of information right here. So f of -1 equals 1 is the ordered pair -1, 1. Okay, that's just literally a translation of notation. Okay, if you have f of 0 equals 2, what point is that? 0, 2. So write that down below. Okay, so we're just talking about the f functions. Okay, and then if we have f of 1 equaling 5, that point would be 1, 5. Okay, so then what we're going to do next to it is write what the slope is at each of those points. Okay, so what is the slope when the x value is -1? 3/2. What is the slope when the x value is 0? 2. What is the slope when the x value is 1? 1/2. Okay, so now, since they tell us that the g function is the inverse, all we're going to do is start by flipping the x and the y for the ordered pairs. Okay, so for my first point of g, my x value will be 1, and my y value will be -1. What is my second point? 2, 0. And what is my third point? 5, 1. Okay, so what are my slopes? So what is my slope of g when my x value is 1? 2/3, very good. Okay, what about when my x value is 2? 1/2. And what about when my x value is 5? 2. Perfect. Okay. So we can answer these questions down below using our nice little table that's very nicely organized. Okay, so for A, they ask us for the derivative at 1. So if they ask us for the derivative, what are they asking us about specifically? The slope. So what is the slope of g of 1? What's that? 2/3. Yep, good. Okay, what about the slope when g is 2? At g of 2, 1/2. Okay, what about at g being 3? The slope when the x value is 3. Couldn't tell you. You're exactly right. You don't know anything. Not possible. We do not know. We don't have that x value. Okay, what about when the x value is 0? Still not possible. We have no x value of 0 for the g. Don't know that. What about the x value of 5? 2. Good. Okay. Good, Matt? Okay, so here is another little thing they're going to ask you about, like, is this function a one-to-one function? So, do you guys remember this from last year at all? One-to-one. We used it with inverse. So all it means, a one-to-one, is that the function is strictly increasing or strictly decreasing. Okay, so the fancy word for that is monotonic, which sounds pretty smart. We should probably use that. So like, is a parabola monotonic? No. Okay, is a John Travolta monotonic? Depends on which one, right? If we have like x cubed, straight up x cubed, that one would be monotonic because it always increases. But if it came up and then went down and went back up again, that one's not. Okay. All right, so how do we figure this out using calculus? Okay. So for question A, we're going to start by finding the derivative and then make a decision if this is a one-to-one function. So what's the derivative of my given function? Okay, so 6 minus 3x squared. Okay, so basically what we want to be thinking about, if I'm looking for a derivative, what is the first derivative going to tell me about any function? The slopes, and what else can it tell us? X, that's second derivative, the extremas. Okay, so if we have an extrema, then we know that the function goes up and down, or vice versa. If there is no extrema, then we know that the function is going straight up or straight down. Okay, we might possibly have, well, let's just keep going. So how do I find the extremas? Set the first derivative equal to 0. So if I solve this, I'm going to add 3x squared. I'm going to divide by 3, so that makes 2. And then I square root 2, so I actually have 2 possible values here, right? I have a positive square root of 2 and a negative square root of 2. So I'm going to do my number line and see what happens. Okay. What is a value that is smaller than the square root of negative 2? Negative 3 would work. So if I plug negative 3 into my derivative, the first derivative one, so the very top piece, if I plugged in negative 3, what would you get out, a positive or a negative? A negative. I'm going to use blue here. Negative. Or not. If I plug in 0, what would I get? Positive. Uh-oh. Definitely not one-to-one. We could even stop right there and say, if we are going from negative to a positive, that's an extrema. This one is going to be a negative.
Wait, how do you know whether it's one-to-one?
If it was strictly increasing or strictly decreasing. So if we had plus, 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 or minus, 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 or just a minus. Yeah, they would all have to be the same. So you say not 1, 2, 1. Okay, so it would have to all be the same. So then it says, find the interval containing 0 for which the function is one-to-one. So where is the function one-to-one which contains the x value of 0? Very good. Okay, so the interval that basically contains 0 is from negative square root of 2 to a positive square root of 2. Okay, so you could... Right, exactly. So you could say, well, I could have a one-to-one function if I restricted the domain to that. Then it would work. Okay, or for C, what if they wanted the interval which had negative 2? Which interval contains negative 2? Yeah, the bottom end, from negative infinity to a negative square root of 2. Is that it? That's it. So easy. Okay, so your problems that you have to do are 1 through 13. Okay, if you choose to go all the way through, you can earn yourself extra credit. There's 32 possible.